Now, related to anonymous functions, we have the concept of closures. Closures also use anonymous functions and use a specific aspect of anonymous functions. And here's an example. I'll add another function, not an anonymous function, but instead a regular named function, which I'll name createTransformer. Now, createTransformer has the goal of producing functions. And for this, I will return an anonymous function here, because in all the places where functions are needed, so both in parameter values as well as in return values, you can use anonymous functions. Now, createTransformer should return functions that take integers as inputs and return integers as values. So it should produce functions that look like this. Hence, the function which I return here will take a number as an input, which is of type int, and it will return an integer, this anonymous function. And then in here, we could return number times 2, but that's now the part where createTransformer will become active. The number with which I want to multiply that number should be a parameter of createTransformer now. So here the factor is another integer, and I can now use this factor inside of this anonymous function. Please note that factor is not a parameter of this anonymous function, but of createTransformer. But because of scoping and because of the fact that we can use variables and parameters act like variables and are just variables in the end, in lower level nested scopes, means that we can use factor, which belongs to the scope of createTransformer, inside of this anonymous function, which has its own scope, but which is part of the createTransformer function scope. So we can use factor in this inner anonymous function, even though it's not a parameter of this function, because it is a variable or parameter of that outer scope, of this outer function. And now the function which I return takes both its own parameter, number, as well as a parameter of createTransformer. And now we can use createTransformer as a so-called factory function, because createTransformer now is a function that produces other functions with different configurations. And that means that we can now easily create different number transformers. Here in my main function, I can, for example, get a double function by calling createTransformer and passing in 2. I can create a triple function by calling createTransformer and passing in 3. And of course, we can pass any value we want here. And then I can get my transformed numbers not just like this, but I can also get my doubled numbers here by calling transform numbers, passing in the numbers, or the address of the numbers, and passing in the double function, which I created here with help of that factory function. And we can do the same for the tripled function, where we now pass in triple as a second parameter value to transform numbers. And hence we can of course output doubled here and also output tripled at the bottom. And that's how we can use such a factory function here. Now, I did mention though that this lecture would be about closures and not factory functions. Well, factory functions are just a pattern, but we also actually have a closure here. Every anonymous function is a closure, and that simply means that if you use a variable from a scope in which the function is created, so from an outer scope, like factor here, then the value of that outer scope variable or parameter is locked into this created function. So that means that if I call createTransformer with 2 different values, as I do it here with 2 and 3, then the function that is produced will not be changed by those later calls. If I call createTransformer with 2 here, then this function will return me a function that multiplies the input value to this transformer function with 2, because I passed in 2 here. If I then call createTransformer thereafter again with a different value, that will be a totally different scope, a totally different function execution. Just because I call it with free here will not change this double function which was produced before. Because this anonymous function closed over the variables or parameters of the scope in which it was created. So factor will be available when I then later execute double, which I in the end do in transform numbers when transform is invoked, because I'm passing double as a function to transform numbers. And that double function will work and will double its numbers because, again, that factor and the concrete value of that factor when that function was created will be locked in because it's a closure. That's simply what a closure is. This value will be locked in and will be available at any point in the future when we execute this function. Even if we call createTransformer thereafter, this locked in value won't be changed. And therefore now here, if I run this module again, I get my doubled and tripled numbers here because I locked in these values with help of this anonymous functions feature, with help of this factory function pattern, which we're using here, and with help of that fact that functions are closures in Go, and hence we can lock in values of the outer scope for future function execution.